Okay, so we're going to talk about DevOps challenges in the microservices world, specifically in public cloud per se, or Kubernetes environments in private cloud and so on. So, firstly, like what is it that has actually changed in the microservices world traditional compared to the traditional data centers and IT and so forth? So, one of the main things that have actually changed is the amount of variance and the volatility. Gone are the days where we used to talk in terms of front end, back end, middleware, and then there are like just a very few moving pieces. Things could happen on a weekend, any changes and so forth. And today we're living in the world of CI/CD. Amazon itself has like 100 plus PaaS services. Developers are building microservices and so forth. So one of the key challenges that actually brings in is that the amount of subject matter expertise that you need to manage all these moving pieces. Like, I mean, we know that we have infrastructure as a code, which actually helps us automate a lot of stuff and helps us to some extent. But, the amount of subject matter expertise that you need to basically write infrastructure as code is pretty substantial. So you're really looking at a discipline or an engineer who's good at operations, who understands security, and all programming. So programmers are not like operations people, and operations and security people are not developers, right? So that basically makes this DevOps skill to have so much of variance. I mean, you can have people as low as $50,000-$70,000 to as high as 200 plus $200,000, north of $200,000. So, and then it's also sometimes difficult to retain ones, right? So, and then we talked about how fragmented infrastructure makes it all like really very difficult. And Kubernetes by itself is an operational beast, and I think pretty much everybody would acknowledge. I mean, it has a certification on its own. So so that's like some of the challenges, for example. So so now, but while you have all these operational challenges, the developers need to have self-service in order to be productive. They need to basically go do deployments, make changes to the infrastructure. I mean, DevOps per se, you could say that in true senses is like dev doing ops, right? So how would they do this when they don't have the subject matter expertise? So and like you'll see very commonly that people talk about like, yeah, we have an infrastructure and everything is automated. Okay, how is it automated? It's automated using infrastructure as a code. But that's an automation that actually makes DevOps engineers efficient. That's not an automation that developers consume, or they rarely consume, basically, right? So, so that it's primarily scripts. You have to watch them. They're attended systems. The best automation that by and large that we have seen, the most mature space is the CI/CD space, wherein, okay, if you have like a stable infrastructure, stable topology, you can go and make maybe Docker image changes as you push code and so forth. But the moment you have to make any changes lower down, be it, adding a port to the load balancer, deploying a new microservice, maybe have an S3 bucket or an RDS instance or an Elastic cache. I mean, it becomes like really very difficult, and cut across multiple clouds. It's even more challenging. So one of the things, of course, in terms of, in addition to the subject matter expertise that you need for DevOps, is this thing about like security, right? I mean, with so many different pieces, like how do you make sure that security gets done right and we don't miss compliance controls? Like Amazon's PCI guide is like 3,400 pages long. So traditionally, the way security used to be done is that you could do whatever you wanted in storage, compute, network, operating system, by and large, and then you would drop a Palo Alto box right in the middle of the network, push all traffic through that, and you would sort of be secure. But now security needs to be embedded across the board. So that's where, there is this aspect of shift left security, wherein people want to bake in security best practices along the way as they are building infrastructure, security, compliance standards, so that they don't actually have to do more work. But this is easier said than done, because like in order to implement all these security controls, you need to know the security controls, right? So how many people actually know have read the compliance standards and sort of seen how security should be? Because security by itself can be very opinionated and abstract. I mean, there's a standard like SOC 2, which will tell you how, just say that, okay, segregate two environments and leave it at that. Or they can be PCI, which would be like as granular as, okay, you need to have VLAN-based, network-based separation, egress traffic has to be filtered, like that sort of a stuff, right? So shift left security, while it is a desire, but it is not like easily achievable in today's world, because there aren't like any frameworks per se to actually achieve that. So so that's what we kind of covered. So what people are now tending to do is that, okay, is it possible to actually put in another self-service platform on top of your public cloud, wherein all of these security controls, DevOps systems and whatnot are baked in? And these systems, I mean, there's almost a discipline that goes beyond DevOps, and people are calling it platform engineering, where the idea is to actually build a self-service platform. And now I think what we are seeing more recently is that almost every big company is trying to build a platform in one way or the other. It just got its own discipline more recently, like platform engineering and so on. And then, of course, there is a conversation about like build versus buy, because I mean, given how much overlap is there across various different organizations who are actually trying to do this, I think buy could potentially be an option. And of course, take it with a grain of salt, because I come from DuploCloud, who has actually built such a platform. So I have my biases. So let's dig a little bit deeper about what is this platform basically. So what we are trying to sort of say is that, forget for a moment that we're talking about DuploCloud, but the general idea is that, is it possible that we could actually put in a sort of an abstraction layer on top of your public cloud, Amazon, Azure, GCP, or on-prem, wherein you could have like maybe the software running in a virtual machine that exposes itself using a low code or a no code UI, wherein engineering teams can go and build, operate their infrastructure end to end. They could basically go and launch maybe even new Kubernetes services, new databases, Elasticache and whatnot. There are like guardrails that have been set by the administrative team, but they're not in the path of like daily deployments and stuff. And you could just specify it at a platform level. Hey, you know what, whatever happens here, I need it to be PCI SOC to HIPAA compliant, and the system by and large, at least 90% or more makes that happen. So that's the concept of a platform or DevOps as a service. You can compare it with, you know, how infrastructure as a service happened. Like, you know, today creating a VPC is probably 3 or 4 parameters, what used to be hundreds of configuration in the on-prem world around VRFs and VLANs and whatnot. So something similar, like how Amazon and Azure created infrastructure as a service. The idea here is to create a DevOps as a service platform. So, and DuploCloud, of course, we claim to have built that kind of a system. And I'm going to play a demo here and then sort of go from there.
Let's look at a product demo. In this sample scenario, we've decided to deploy a few applications to AWS. The architects have come up with this infrastructure blueprint for one of the applications we need to manage. In the diagram, we see a dedicated VPC, 2 availability zones with public and private subnets in each, deployed in the US West region. We need to provision Docker containers on AWS EKS, in addition to functions on AWS Lambda to obtain a serverless model for the microservices. MySQL Aurora database and S3 are the data stores, and the application is exposed to the internet via a load balancer protected by a web application firewall. Now that we've gone through the desired architecture, let's get to work by using DuploCloud's user interface to deploy the application. We could also use DuploCloud's Terraform provider or API, but we'll focus on the UI for this demo. We start by logging in, and as an admin,
I want to introduce 2 constructs to you. One is that this makes it all very simple. One is the concept of an infrastructure. What is an infrastructure? Infrastructure is basically a VPC in a region with a Kubernetes or an ECS cluster. So anytime you need a new cluster in a new region, a VPC, you just go and give these 4 or 5 parameters, and the system automatically deals with VPCs, availability zone, NAT gateways, routing tables, subnets, and creating a cluster, admin service account, and all that kind of stuff. So that's an infrastructure. Second is the concept of a tenant. What is a tenant? Tenant is an environment, and tenant is a child of an infrastructure, as in one infrastructure can have many tenants. Tenant is like an environment. You go into the context of the tenant, you create all the resources. So if you delete the tenant, everything goes away. Resources as in your databases, your pods, you know, your even VMs and S3 buckets and Redis instances and all that kind of stuff. That's one. Second, tenant is a security boundary, meaning that 2 resources, if you create within the same tenant, they'll automatically have access to each other. The system would do that. And third is tenant is an access control mechanism. So if you have like a lot of developers, you can have some developers have access to one tenant, have access to another tenant. Like, and how would this map to your world. If you're like a smaller environment, maybe dev, stage, prod could be different tenants. Or if you're like larger environments, you have a team called analytics, and analytics dev could be one tenant, analytics prod could be another tenant, and so on. So I told you infrastructure was a VPC and a cluster. Tenant is the next layer of isolation. Each tenant is a set of security group, IAM role, instance profile, Kubernetes namespace, a PEM key, and so forth. Oops.
This infrastructure blueprint for one of the applications, in addition to functions, to create the network infrastructure. Behind the scenes, the platform will auto-generate the required AWS configuration and complete the setup. This includes the VPC, availability zones, and subnets. We then move to deploy the application infrastructure. The application is called Invoice, and we start by creating a logical workspace known as a tenant, where both admins and the appropriate developers can access in the finance network we just created. Next, we're going to switch to the Invoice application, where we'll create the various cloud services starting with a virtual machine. Notice that the user provides a high-level specification only. Behind the scenes, the platform will generate the security group, IAM role, instance profile, and other AWS configurations. From here, we'll create an S3 bucket. The platform auto-generates the IAM access policy for the host to access the S3 bucket. Detailed security controls such as encryption, public access block, logging, among others, are applied to meet the compliance requirements. We can provision a SQL database. The software understands that in this case, it needs to generate security group-based policies.
As an example, like for example, if you were to dig deeper into what's happening behind when we create a database with just these few parameters, username, password, engine, version, maybe some size and whatnot. Behind the scenes, the system will take the username, password, encrypt it via KMS, save it in Secrets Manager, install an IAM policy to make sure Secrets Manager can be accessible by the pods and the tasks that are going to run. If it's a Kubernetes environment, install the Kubernetes driver to map the Secrets Manager secret into Kubernetes secret. So all this, which would have taken so much of knowledge and I don't know how many Terraform files and YAML files, is just taken care with these like 7 or 8 inputs.
As against IAM. It will also set up backups, encryption, and other best practices behind the scenes. With network and network infrastructure in place, we next move to deploy first the Docker-based microservice. Here again, the user provides an application-centric specifications, while the software auto-generates Kubernetes and AWS configurations that includes the deployment or stateful sets, node ports, ingress controls, and other such infrastructure details. The right set of access policies, security groups, ACLs are applied. It is important to note that the platform is performing all these actions with no presumptions about the application topology that it is being asked to deploy. And many other functions are built into the platform. For example, we can see a quick view of the container logs, or access the shell of the running container itself. Just-in-time access to kubectl is provided for more granular control and debugging. Across the platform, you can easily click Console to access the various cloud services inside of AWS. An example of a time we would want to do this would be in order to upload a Lambda package to an S3 bucket, the first step in deploying our Lambda function. Notice that the platform implicitly provides just-in-time access for users for AWS console access with the right permission set. There are no access permissions to manage manually. After uploading the package, we specify the Lambda function parameters and the software will do the rest. As we complete all of the infrastructure, and the application has been deployed, we can look to do a sanity test. Our application works. The platform has been performing other necessary tasks for the infrastructure. For example, several diagnostics functions are implemented by default. Here we're going to take a look at a metrics dashboard that has been set up using Prometheus, Grafana, and CloudWatch, with no further user input required. Leveraging Elasticsearch, logs are collected and segregated per tenant and per service. Alerts for various infrastructure resources can easily be configured as well. The platform is using tools like CloudWatch and Prometheus for this, allowing the user to simply specify the filters for each alert. Similarly, there is a billing dashboard to track costs across cloud services or across applications. Next, businesses in highly regulated industries need a security and incident management platform, and that comes built in. All configuration changes in the cloud infrastructure are detected and the controls are applied. Compliance dashboards are readily available for auditors. Notice that all of this is set up without the user having to lift a finger. There's an audit trail of all actions in an application-specific context. Here we are showing the audit trail for the invoice workspace. Finally, there are various options to configure CI/CD for your daily code releases. Everything that we've gone through the UI today can also be done via Terraform. Here is the script for the current setup, deploying a fully secure and compliant infrastructure underneath, with a fraction of the code that would have otherwise had to be written and maintained. Autonomous DevSecOps are the future of cloud automation. To learn more, visit DuploCloud.com.
So yeah, I think that was sort of the gist of the platform. I think the website has like a lot more information. This is like a case study in an organization called Unifor. They were building launching a product in public cloud. Pretty soon they came in like 50 odd users, largely developers. They're able to come in and launch and run these, hundreds of containers and services with a very, very light footprint, fully secure, compliant a system, basically, right? So almost like the Devops-as-a-Service experience that we talked about. Yeah, and this is a bit about our company. I mean, reasonably mature, north of 80 customers, getting closer to 100,000 plus platforms, 50,000 plus infrastructure changes. This could be like just anything. This is not somebody just changing a Docker image in a CI/CD pipeline. This is about, adding an RDS instance, adding a S3 bucket or an Azure service bus, or creating a new Kubernetes cluster. It could just be anything. And that brings us to a point that we have support like 200 plus cloud services across the board. Like this could be Amazon's S3, Azure Storage, MSK, OpenSearch, Google, a scheduler, you name it, and we pretty much have everything. Security is like our bread and butter. We do 45 plus compliance certifications through our customers. That's what they pass through. Almost like one customer a week is going through some sort of a compliance certification. So yeah, and I think a very well established growing company. And yeah, I think that's it. Hopefully you got a gist of like the challenges that are there in the microservices world. And then I think our the summary is that the people are going more towards platform engineering, and I guess the idea, and like in some senses enable a DevOps as a service solution. I think the question really now is that whether you build it in-house or you try to buy. Thank you. Bye.